Welcome students, this is the Properties of Inequality video. This is the one where we're going to talk about solving inequalities. So as before, because this has been proven so far to be a skill that we have actually pretty well down already, feel free to pause it after every inequality I post or I put up on the screen, copy it down and solve it. Just please make sure that you recognize the names of the properties of inequality. Make sure you recognize the names because it does make a difference in later assessments that you know the names of these properties in addition to just knowing the properties. So let's jump right in. Starting with the addition property of inequality, which is exactly the same thing as the addition property of equality, except that it's for inequalities instead of equations. So if you add the same number to both sides of an inequality, it's still true. It stays the same as it did before. Like here it was a less than, still a less than. They give you a numerical example, and they even give you an example with inequalities on a number line to show you the diagram that if you add C, B is still less than A, the way it started out here. So B is still less than A even if you add C because it started out that way. So how would I start this inequality where I'm actually solving for X? Solving for X here, we have X minus 15 is greater than negative 12. We're going to reverse what was done to our variable, so we're going to add 15 to each side. Please forgive me, I'm using one of my less high-quality styluses. It might be styli, I'm probably saying it wrong, but bear with me anyway. All right, so we add 15 to each side. We get X is greater than 3. And we graph our solution set as we've learned in class. Ms. LeCompte does not need a fancy graph. Just 3 notches on the number line. 2, 3, 4. Open circle, shaded up for greater than. Fill in the arrow, and we're done. So X is greater than 3 because we added 15 to each side. Okay? Then we have the subtraction property of inequality, where if you subtract the same number from both sides, it's still a true inequality. Again, numerical example, and then with the number line. A starts out less than B. When we subtract the same number from each of them, still less than. To solve the one that we have here, we're going to, we got t plus 6 is greater than negative 4. We're going to subtract 6 from each side of our inequality, giving us t is greater than, instead of negative 4, it's now negative 10. On our inequality graph, remember, 3 notches, negative 10 in the center, negative 11 is 1 less, negative 9 is 1 more. Be careful numbering those number lines. You don't want to have that backwards because I will mark that wrong because it's just not correct to have it the other way. Okay, remember, negative 11 is further to the negatives. It's smaller than negative 10. And this one would again be an open circle and again shaded up because it is also a greater than, just like the previous one we did. So adding and subtracting, no real difference from equations at all. Here's where we get to the real difference. Multiplying and dividing. Look carefully at the multiplication property of inequality. Up here we have, if A, B, and C are real numbers, and C is a positive value, C is greater than 0, then it acts just like the multiplication property of equality. If you multiply by the same value on both sides, you still have a true inequality. And you can see again the numerical example that they show you. However, if you are multiplying by a negative, you need to flip your symbol around. Look at this very carefully right here. Look at this very carefully that I'm circling. If A is greater than B, and we multiply both sides of that inequality by C, which is a negative value, you have to flip the sign. So we're going to see that in one of our 2 examples here at the bottom. So if you want, copy them, try them, and then start the video back up so that you can see the correct solutions. But I'm going to go ahead and jump in and do them now. In this first one, we have X divided by 3 is less than negative 2. We're going to take both sides of that and multiply. What are we going to multiply by? Whatever they divided by. So we're going to multiply by 3. That means these 3's cancel and I have X is less than negative 6. I multiplied by a positive 3, therefore I am not flipping my symbol around. What you can now do is pick a number that fits this, like negative 9. Does that work in my original inequality? Let's try it. Negative 9 divided by 3, is that less than 3? Come on, LeCompte, get it together. Is that less than negative 2? Is negative 3 less than negative 2? Yes, indeed it is. Therefore, I know my inequality answer, my solution is correct. Not going to graph these. We've got our graphing pretty well down. Let's move on to the other one. Now we have negative 3/4 W. Negative 3/4 W is greater than or equal to 3. We learned in this course that we can multiply both sides of this by the reciprocal of that coefficient, and that's going to be the easiest way for us to solve it. The reciprocal of our coefficient is negative 4/3. Here it cancels, and a negative times a negative gives me a positive W. On this side, the 3's cancel. A positive times a negative gives me a negative number, and in this case, because the 3's canceled, it's negative 4. But because I multiplied by a negative, it's no longer greater than or equal to, it is now less than or equal to, and that inequality is done. So multiplication property of inequality, the only real difference here from equations is when you multiply by a negative, you've got to flip your symbol around. Let's look at division. Division has the same idea. It is still the same for if I'm dividing by a positive, but I've got to flip my symbol around when I divide by a negative. So let's try out our two examples. Again, copy them, try them yourself, and then restart the video. Copy them, pause it, try them yourself, restart the video, and then we'll see how you did. All right, we're going to divide both sides here by 450 because we have 450 times D is greater than or equal to 75. So it's how many times does $4.50 go into $75? Well, I can go ahead and try to figure this out by trying to figure out how many times 450 goes into 7,500. Okay, all I did was multiply by 100 on the top and the bottom, which is allowed because technically multiplying by 100 over 100 is multiplying by 1. Think about that. That's equal to 1. Okay, so I haven't actually changed anything. But I'm going to be super duper lazy, and I'm going to let Siri help me with this one. So hold on just a second. Okay, I'm back. All right, ready? Siri, what is 7,500 divided by 450? Let's see what she says.
Let me think about that. It looks like the answer is approximately 16.6.
She's not very loud. She says it looks like the answer is approximately 16.6667. In other words, it's a repeating decimal. So if instead of this I'm going to use an improper fraction for my answer, it's 50/3. 50/3. And we did have a question on one of our classworks where you had to graph an inequality with a fraction. Just remember that it's okay to say, well, that's 16.666. What was it, Siri, again? 16.6667. So if I make this 16 and this 17, 16 and 2/3 would be right here-ish. And then we'd have greater than. So that's how I could do that particular graph. Let me fix my 7 there. Good. Okay, now, last one on this page. Negative 9y is less than or equal to 63. So this time again, we're going to divide. We're going to divide by the coefficient, but it's a negative 9. Think carefully about what that means in the process of writing this out. 63 divided by negative 9 is negative 7. It is no longer less than or equal to, though, because I divided by a negative. It is now greater than or equal to. You can now plug a number in that fits this inequality and make sure that it works. And that's a good way to make sure that you're not forgetting to flip your inequality symbol around. Awesome. Let's look at some multi-step ones. All right, so we have two multi-step inequalities on this screen. Copy them down, pause it, try them yourself, or write it with me. In the first one, 6n minus 1 is greater than 3n plus 8. We're going to start off by getting rid of the smaller value of our variable. So I'm going to subtract 3n from each side, leaving me 3n minus 1 is greater than 8. I continue by adding 1 to each side. 3n is greater than 9. And now I am going to divide by 3. X is greater than 3. Now, if you follow my rule of always starting with the smaller value of the variable, you will never have to worry, I shouldn't say that. You will rarely have to worry about flipping a symbol when you're solving a multi-step inequality. So it's important for you to remember that I taught you that for a reason. I'm trying to keep you from sign errors and sign mistakes. Let's do the next one. I'll switch colors, make it fun. All right. We have 3 times the quantity t plus 1 minus 4t is greater than or equal to negative 5. So we need to go ahead and distribute. So 3 times t plus 3 times 1, and then minus 4t greater than or equal to negative 5. I have like terms to combine. 3t minus 4t is negative t. Negative t plus 3 is greater than or equal to negative 5. So we're going to subtract 3. And this is one of those times where my trick didn't work because I still have a negative variable. And so in this case, I'm going to have to think about what I can do mathematically to get positive t. And I can multiply by negative 1 on both sides, giving me t on the left, positive 8 on the right, and a flipped symbol. So now that I have this, I can go in and look at my answer choices. Does the number 8 fit the answer choice? Yes, it does. I think that's our answer. Does 9 fit it? Well, let's try. Is 9 less than or equal to 8? No, it is not. How about 10? Is 10 less than or equal to 8? No, it is not. Is 11 less than or equal to 8? Nope. But the number, that didn't quite work there. But the number 8 absolutely fits. So your answer choice there should have been A. Couple more things to look at. Let's look at some funky solutions for inequalities. All right, so on this page, I do actually want you to go ahead and copy. Let's make sure we get the inequalities with strange outcomes portion, because you probably didn't talk about this in your previous class. I'm sure at least 10 of you will correct me and tell me that you did indeed talk about this in your previous class, but let's go over it anyway. What are the solutions to 10 minus 8a is greater than or equal to 2 times the quantity 5 minus 4a? We have to distribute first. We are going to then get rid of the smaller value of our variable, and we run into that familiar problem we had with our special cases, that we have the same value of the variable on both sides. So we're going to add 8a to both sides, leaving you 10 is greater than or equal to 10. Well, that's always going to be true. There's no variable left. So in this is similar to an identity. The solutions to this particular inequality are all the real numbers. It's not an identity, so you're not going to write the word identity down. That's only for equations. We don't have inequality identities. But we do have inequalities where all the real numbers will make it true. I bet you can already guess what's happening with the next one, and of course it's sitting there right on your screen, so it's not like you can't read it. 6m minus 5 is greater than 7m plus 7 minus m. We simplify by combining like terms right here. 7m minus m, 6m. We have 6m minus 5 is greater than 6m plus 7, and you probably already recognize that that is something kind of funky. So let's finish off by subtracting 6m from each side, and we get this strange result here. Negative 5 is greater than negative 7. Well, that's not true. Negative 5 is indeed not greater than negative 7. Therefore, this inequality is one that has no solution at all. So you can guess what's on the last slide of your video. It's one of each of these to try for yourself. So let's go ahead and take a look at them. And there you go. Copy them down and try them. Pause your video. I do want you to all do this for me. And then start it up and see how you did. Okay, I'm going to jump right in. So in this first one, I've got no simplifying to do on either side. I have 5n and 5n, so that's what I'm going to deal with. I'm going to subtract 5n from both sides of my inequality, leaving me 9 on that side and negative 1 on that side, and less than or equal to. Well, no, it's not. That's not true at all. So this inequality does not have a solution. Last one. 8 plus 6x is greater than or equal to 7x plus 2 minus x. So this time, I do have simplifying to do on this side. 7x minus x is 6x. So now I have 6x plus 2 on the right and 8 plus 6x on the left. Find your smaller value of the variable. Yeah, I know. They're both the same. Subtract your 6x from each side. Don't worry so much about why you're doing it. Think about what you get after you do that. You get a true inequality. That's always true. So since that inequality, that's not the word true. Let's try that again. Okay, let's try erasing it. Okay, try to write the word true again, a little bit slower this time. That's better. All right, it's always true. So this one has as its solution all the real numbers. So I know I went through those rather quickly. I don't think we're struggling with this. You'll have classwork to do in class when I get back from my trip. I am making this video while you guys are at the Become Your Dreams assembly. I know I cheated. I ducked out. You can complain about it later, but I bet you enjoyed your assembly, and I missed it to make you a video. So maybe you should just be grateful. So all right, guys, I will see you in class.